Hello everyone, welcome back to our YouTube channel Becoming a Rose Developer. I'm Desire and today I've got Maurice who has just completed the course C++ Basics for Robotics and will be giving us a presentation on this. So what I'm going to do is to hand over the platform to him so that he can begin his presentation. Alright, whenever ready Maurice.
Great. Um, okay, so hello everyone. So yes, I'll first speak a little through my programming, my code, and then I'll then start with the simulations. Okay, so first node class. Um, start from this is all the given includes the pointer to robot interface. Okay, so then I started with implementing all the functions and officially giving them certain values or void if they are just doing something. Um, all my moving functions, I started with the output of what the move is, what is following, um, and then often also a end something that says completed the move, so that yeah, just for in the it's all exposed to the terminal. Programming wise, or in terms of movement, yes, I didn't use a set variable. I used the pre-given max velocities in the other file in this robot interface class. So I directed it to that max value, so it switches automatically between the max value of the real robot compared to the max value of the simulation.
Right.
So all of these are pretty much the same. As soon as well, there's four: move, turn, turn right, and turn left, and then also move back. They all are run about the same. It just moves for a set time of 3 seconds, or turns for 3 seconds, and move functions moves forward or backwards for 2 seconds.
Okay.
And also have the timed functions, which takes as parameter integer in milliseconds. Same basis, just this time the user's input determines how long it moves for.
Right.
Then we have the move forward distance and move back distance. Started with creating a variable with speed in, the provided to then calculate the time that the robot must move in order to achieve the distance. And then it just outputs that time in milliseconds. That the calculation is according to milliseconds. So then it outputs the time in milliseconds back to the sleep function in order to move the robot for a certain amount of time. So the move back works the same principle.
Hi Maurice. Hi Maurice. Can you hear me?
But for turn right movements, obviously create the angular speed and declare it as negative. So it turns in the opposite direction. Double, then stores it and uses a for loop to populate the list. Returns that populated variable, local variable with the ranges, and then outputs it back to wherever the user wants it. More getter functions.
Hi Maurice, can you hear me?
Minimum, and the max value does the opposite, just sets the new value as a max value. Get current position, again, same principle. but this time just outputs it as a map rather than a list
Mm-hmm.
in order to have the storage variables. Some formula provided to return the amount of distance that the robot have traveled and takes as parameter the initial position in X and Y because it's a two-dimensional movement
Mm-hmm.
and X and Y afterwards. Okay, so that's all my functions that I implemented in the node with our classes. This is provided programming. Then in main, um, all of this is all of this is pre-provided. So from here is what I implemented. Created a few variables to store the location, the previous location, and the current location. And then this is the part two of no classes. So here's all the programming which tests all the different functions that I've implemented. Firstly, it starts with all the movements in different ranges. So there's and always has a sleep function in between of them so that the robot yeah, just doesn't go too crazy. So
All
move
right.
forward, move back. Do
All
you have
right.
questions?
Yeah, can we see this running, all right, so that we can see how the no class performs, and then we'll come back to the class version. Yeah.
Okay, perfect. Yes, we can run it. On the real robot first, eh?
Yes, the real robot first. Yeah.
Okay, let me just get my terminal here. Or I'll just
You can
right.
just click on it and think it will show up. Yeah. Okay. There we go.
Okay. Um,
So okay. Can
Sorry,
you?
is it okay if I copy and paste the commands or must I type them?
Yeah, yeah. It's all right. I just can't see your camera stream window at the moment. So can you
You
click on
cannot see?
the camera stream window for the robot?
Oh, the camera, this one.
Yeah, yeah, the lab stream window. Yeah. So maybe find somewhere to put so I can see. Maybe on the top left. It's fine if you can copy and paste commands. No worries.
Okay. Is that good? Can you see?
Yeah, that's good. Yeah.
Okay. In terminal 2, I'll launch the keyboard commands. Just always have that in case something does not work as planned.
Mm-hmm.
Okay, so I'll first run the no class one.
So the no class version is no obstacle avoidance implemented, right?
No, there's no obstacle avoidance. I might just move the robot. Yeah, it's
Okay.
going to
Yeah.
just move in a random pattern that doesn't have any obstacle avoidance. So it just moves accordingly.
Yeah. We just must not have it crash.
Yes.
All right. Okay. Good enough. Good enough. So maybe you can stop execution in that terminal. There's something that I want to ask you about what has just happened when you started executing a program, right? So,
Okay. I cannot stop it. I don't have
okay.
in a spin, but it's done now.
Okay, so you created the thread, right? And I was going to ask you, did it stop? Okay, it did stop. I was
Yeah,
going to
it is
ask
stopped.
you, you are commanding your robot from, that's the current thread, right? Because I see you use a stood this thread, right? So ideally it must stop, which it did. So that's good. Um, is there a reason why you had to specifically call this thread? Why didn't you just do um, your controls without having to call it explicitly?
Um, Sorry, I'm not sure I understand what you directly mean. Do you want to point out?
Yeah, so if
So,
you, so in your control functions, right, you specifically
yeah.
allocate how much time the current thread is supposed to sleep, right? Is there any other
Yes.
way where your functions were running in a different thread that you couldn't control?
Um, so you speaking of this
Yes,
aspect.
right, yes, yeah.
Okay.
So ideally, you should be able to say to call a sleep on this thread without having to use that. Is that not correct? Or you couldn't find another
Um,
way of doing it?
no, this is I found this way through trial and error, but it is
Yeah.
also it's also programmed in the set functions. So I thought it's adequate. I can
Yeah, yeah,
quickly
yeah.
show you where I found it.
Yeah,
In
it
this, it's the same way as this.
cool. Yeah, yeah, it's definitely is. I just wanted to understand to see that you understand fully that having to call sleep for this thread, what does it mean? It basically does the same thing, which is stopping your program from running. But then do
Yes.
you also understand that you can call a sleep on other threads that may be running concurrently with your execution script?
I did not find that way, but yes, I
Okay.
understand the concept.
Yeah, yeah, yeah. Okay, that's really good because it's very important. And the reason why I'm asking about this is sometimes when you said that it was not stopping, I wanted to find out, did you not create a thread in another separate process? And when you do that, and that thread is controlling your robot, and you fail to join to the current thread, which is your main thread, the robot will keep
Yeah.
running even if your program is terminated, right? That's why I was asking you about the
Yes.
concepts of threads in general. But no worries. So far, so good. Let's go to the non to the class version now. That's the one that has got obstacle avoidance, right?
Yes, that is the one that's got obstacle avoidance. Okay. I can
Okay.
go to that one.
Yep.
Do you want me to run through the programming or is it a game? Do you want me just to simulate it?
Let's simulate. Let's have it execute, right? So I want to see how it's working on the real robot. We can talk about it later if we see some interesting observations, but let's
Okay.
run it for now. Yeah.
Question, so you had to I had to program both part one and part two and part three. Do you just want to see the obstacle avoidance for now?
Yes. Yes, that's the one I want to see.
Obstacle.
I'm
Okay.
assuming that for your for other behaviors, you've got it almost the same as the non-class version, right? So.
Yes, it's exactly the same. It's
So
just run
yeah, so
okay.
that's
Okay, so now this is the obstacle avoidance.
hmm
Again, now this is yeah. Okay. Um,
what's going on there? Okay, it stopped in time.
with that wall, it sometimes does not stop correctly, but most of the time it works.
Did you manage to find out why that was happening?
I don't know. It only crashes into that wall and none of the other walls. So I'm not sure, but it doesn't always crash into it, but sometimes.
Okay. Um, what I would recommend is maybe you can set your linear velocity slightly lower, so maybe use 0.1 or 0.12. Right now you're using
Okay.
0.2, right? The max possible velocities for the robot.
Yes, I'm using the max possibly
Yes.
velocity.
Yeah, so you see, given how much given the frequency for which your control loop is running, sometimes it doesn't even have time to stop the robot in time. So 0.1
Okay.
allows your robot to have that much time. But it works well. It works well. Um,
Okay.
and it says terminate without an active exception. What's happened there? Did you have a memory leak?
I I spent a lot of time in searching for that error,
Yeah.
but at the end, I took away all my personal additions to the application and ran it, and it still gave that.
Yeah,
Um,
okay. Yeah, I'm
so
thinking
I
there's
assume there's
probably
something with the programming that is given that is not 100% right. Because
yeah,
I
there's
added
probably a
it
memory
says
leak somewhere. Yeah.
okay, but yeah, unfortunately couldn't find where that is.
Yeah, no worries. Then the other thing that I wanted to ask you about is, do you understand the warnings that you're getting every time you execute your program, like unused?
Yes, I understand. So because I'm quoting, so I've declared the variables here,
Mm,
but they are used in the quoted
mm-hmm.
or the commented
Commented
programming.
output. Right.
So it just thinks I haven't used them.
Right, right, correct. The reason why I ask this is sometimes people just ignore these things and yet they're very important because
Yeah.
sometimes the better you keep your console output clean, the more likely you are to find real concerning bugs rather than to let it be
Yes.
uh, clouded by all those. So if you know where that is coming from, then that's fine.
Yeah.
All
No,
right.
it's these variables.
All right. So show me, take me through the logic for your obstacle avoidance, right? I want to understand how did you manage to get it to work and to work the way it
Okay.
does. So,
Okay. So I'm going to go to the obstacle avoidance function or
mm-hmm,
method. Okay, so first of all, I tried to not use set values or make it a to use constants and variables rather than hard coding different things.
mm-hmm,
So I have a lot of variables, but first of all, I started with both the two variables for safe distance and caution distance.
mm-hmm,
Um, and then I use to see if it's a simulation or if it's not, if it's a real robot, to create different safety measures or safe distances in
mm-hmm.
order because they use different speeds and different distances.
Yeah, yeah. Can I ask you something here? So, why did you choose to use a const double? Why didn't you go for something like const extra, right? Why did you not choose to declare them as compile time values rather than runtime ones?
I think it is. Well, did you ask why don't I choose to use them as const doubles rather than const?
Yeah, as in why? Because you know them beforehand, right? Why did you not
Yes.
choose to have them set at compile time, right? So by using const exp, you know const exp, right?
No, I've not
Const
heard of
exp.
that one.
Okay, const expression. You can check it later, right? But basically, I wanted to ask you this because you seem to know what the given values are, right? Whether you're running in the
Yeah.
simulation or whether you're running um, on the real robot. So other than to wait for those values, for those safe distances and caution distance to be set at runtime, you can have them set at compile time, right? So that's the question I was asking. But
Okay.
if you had no idea about const exp, then you can have a look and you'd understand why I was asking this question. But it still works the way you
Okay.
did, right? I'm just trying to probe your understanding in that direction so that you can also learn a bit more as you look in that.
Is it possible to write it in the comment section or in not the comment section, the Zoom call so I can just do more research into it because I would love to
Yeah, sure,
improve
sure.
the programming.
Yeah, I'll send it to you immediately after we're done. And the other reason
Perfect. Thank
why
you.
I'm also beginning to see, um, yeah, okay, yeah, I definitely would recommend that because when I look at your program, everything that is happening in choosing the choice of safe distance kinda
Yeah.
is known at your compile
Yes.
time instance. So okay, all right. I will let you know after this. Let's go on.
Okay. Thank you. So then I set turn times also again, depending on if it's a simulation or the real robot.
Mm-hmm.
I then extracted the ranges into a list, but because a vector is easier to work with, I then converted it to a vector
Mm-hmm. Okay.
of sensor ranges, which I will be using then.
Can you
Um,
explain a bit more what you mean when you say it's easier to work with a vector than with a list?
so with a list, it is difficult to find specific indexes or to, yeah, for like even for the for loops, I find it easier to work with a vector compared to a list. um, just out of personal experience or yeah, trial and error. I
Mm-hmm.
prefer
Okay.
to use vectors, so I then converted it to a vector.
Yeah,
Um,
yeah. Yeah, a
Okay,
vector
and
is
just
a contiguous element, right? Whereas a list isn't.
yes,
So that complicates matters, right? All right, let's go on.
a list is set, yes. So I found that, say again. Okay. So then I also created a map for the front ranges um, to save. I'll explain now why I use the map.
Mm-hmm.
Also used a map for positions that I will use to then measure the amount of distance that the robot traveled in the obstacle avoidance um, function.
Mm-hmm.
So yeah, again, another variable that I said is angle because the real robots, so laser scan angle is different compared to the um, the simulation. So
Mm-hmm.
yeah, that's just a offset value for each. I then use these functions are to set parameters. So let's say for the scanning range, it starts at front. So in order to create the angles at which it needs between, let's say between, okay, let me use it uses 660 angles.
Mm-hmm.
So in order to divide that angles up in sections to
Mm-hmm.
process, I then
Mm-hmm.
used integers and parameters,
Mm-hmm.
which are then rounded just for simplicity, and divided them up in a few different angles, in
Mm-hmm.
45-degree angles as requested.
Mm-hmm.
I
Correct.
then use a for loop to populate the map that I created, no, this map. I
Okay.
then use a for loop and if statements to populate that. Again, because there's the angles is different, I used a if statement. It goes to the from a certain angle to the other side, and it fills in the map with right angles, front, and then publishes vectors in those map. So
Mm-hmm.
it's vectors and it's a vector in a map.
Mm-hmm. Mm-hmm.
As
I
you can
see.
see, the second parameter is a vector.
All right. So that is
Okay.
a map with its elements as vectors.
Yeah. So the first element is obviously string,
Yeah, that's a key,
and then the
right?
second element is a vector of the ranges in that parameter.
Mm-hmm. Mm-hmm. And can you tell me
Does it make
something?
sense? Must I explain more?
Yeah, yeah, yeah. No, it makes sense. Totally. I wanted to ask you in a bit more detail, why did you choose to do a cast after you do your rounding, right? What's going on there?
What did I choose to do?
A static cast after your stood
Oh,
round operation, yeah.
after rounding.
Mm-hmm.
That was actually I'm not sure. That's a redundancy. I'm used to using static costs for rounding, but it's I realize I only have to use one.
Look, you can maybe test it, because I wasn't quite sure of the output myself. I like that you have that security check in place, right? Uh,
Yeah.
But ideally, when you round to something, you're probably going to get a solid figure. However, it's still a
Yes.
float, right, in this case. And I think your
Yeah.
instinct to cast is probably really good. Um, but you have to check to see do you actually need that code there so that redundancies we can
Mm.
have them, but in some places maybe we don't really need them. So, but yeah, good instinct on guarding against having to operate on values that you're not sure what type they are. Okay. Okay, let's go.
Yeah. Okay. Then so the for loop populates the map, um, and then I create a few variables in order to these are just set variables for the minimum value in each of the five ranges.
Mm-hmm.
Um, I then populate it with the if statement. Yes, I populated in the if statement to find the minimum value. So I just use this set function, the vector functions, to find the minimum value in the range. This is well, it reflects back to the vector in the map to find the minimum value in each of the sections. And then this is just for I, I like to see the different values. So I output it to the console, the minimum values. And then lastly, or yeah, lastly in for the obstacle avoidance, I then use an if statement to determine. I added something that is not requested, but
Mm-hmm.
so if it's if the robot is further than a certain amount of distance, it moves a little bit longer,
Mm-hmm.
just so it doesn't move multiple times. But if it's shorter than that in distance, it just goes to moving a shorter amount of time.
Yeah, yeah.
If it cannot move forward, then it moves right if the caution distance if it's larger than the caution distance, or left if the left is better. If none of the options is safe to turn to, then it sees which side is better and turns also a little bit longer to that side in order to make sure it's clear of all obstruction.
Mm-hmm. Yeah,
Yes,
very
if
nice.
just for redundancy again, there's a else with a error output for if the robot cannot, if none of these functions are applicable.
All right, all right. Thank you very much, Maurice. Very nice presentation, and I really like the way you approach this. So the amount of detail and the complexity in this one. All right. All right, everyone. This was Maurice's presentation, and a warm congratulations to him for the job well done. I'd like to encourage all those of you who would want to try this course, C++ Basics for Robotics, to do that, and you can also come and showcase your work. So, until next time, keep pushing your learning. Bye bye.